All right. So again, we have a distributed load given by this force here, or this equation, 4z to the 1/2, and that's in pressure, kPa. It tells you the wall has a certain width of 5. Okay, so we're going to write a unit load. A line load. We call it W, which will be the pressure times the width of the wall. So we're going to end up with 5 meters times 4 z to the 1/2 power, and that's kPa, which is kilonewtons per meter squared. I left my meter off there. So our resulting force will be 20 c to the 1/2, and now we'll have the units of kilonewton meters. So that'll be the value of the force along this edge as a distributed load. So the first thing we know is that the resultant force is the integral over the length from 0 to 4 of our load dx. So again, that's the integral from 0 to 4 of 20 z to the 1/2 dz. So if you remember your integral calculus, you'll get 20 times z to the 3/2 divided by 3/2, which is the same as multiplying by 2/3. Is that right? And then you evaluate that from 0 to 4. Did I do that right? I think so. Right? You increase the power by 1 and divide. So now you just got to plug that in. I don't know what 3/2 power of 4 times 20 divided by all that.
106.7.
106.7. And since we're integrating dz, that's length, we should end up with kilonewtons. Everybody okay with that? Now, our definition for its location, if you remember, was the integral of x, or w dx, and that's over the integral of w dx. Well, that's just what we've done. We have the denominator. We just need to do the numerator. So the numerator component would be, in this case, it's not x because we're working in z, so it'll be z times our 20 c to the 1/2, and that's kilonewtons per meter. Of course, z is in meters, so we get kilonewtons, and then we multiply that dz, we get kilonewton meters. It's like it's a moment. So in our particular, sorry, I've got to integrate this from 0 to 4. So let's put all this together. Let's see, we get, so that'll be the integral from 0 to 4 of 20 z 3/2 dz, which is equal to, oops, I can go ahead and integrate that. So that'll be 2 over 5 times 20 z 5 over 2, right? And evaluate from 0 to 4. That's a funny 20. So what's that equal to?
256.
256? Exactly?
Yep.
So that'll be kilonewtons per meter. So our final value for the location from the top down would be that 256 kilonewton meter divided by our force, which is 106.7 kilonewtons. It's pretty close to 2.5. Probably something a little bit less. What is that?
2.4.
2.4? So what we have now is a little over halfway, about right here. We have an equivalent force of 106.7 kilonewtons acting down a distance of 2.4 meters. I think it's a doable problem, or a problem like that is very doable for the exam. Any other questions about that? I sense from your movements that it's time to go.